All right, section 11.4, we're going to talk about arcs and chords. So if a diameter of a circle, here's our diameter, is perpendicular 90 degrees to a chord, for example, chord DF here, then the diameter bisects the chord and its arc. What does bisects mean? Bisects means to cut in half. So that just means this gets cut in half. The chord gets cut in half if this is a 90-degree angle. So again, if they're perpendicular, so if there's a 90-degree angle, then we know that DE is congruent to EF. And we also know then that chord DG is congruent to chord GF. Okay, if these two are congruent, then we know the measures of their chords are also congruent because they're across from each other. So we have diameter AF. Here's diameter AF. It's perpendicular to chord BD right here. So use a diagram to find the length of BD. Well, if this half is 5 and it gets bisected, then this half is also 5. So the length of BD, we're going to add those two together. 5 plus 5 means that the length of BD is 10. So we can just say BD, if we're talking about length, we don't need anything over the top. We just say the length of BD is, oops, not 5. BD equals 10. Okay. So this one, find the length of SR. Well, if this half of the chord is 15 and this half of the chord is also 15, so the length of SR is 15 plus 15, which is 30. So not too bad. So now it says solve for x, so we're going to have to do a little bit of algebra, but again, this is a 90-degree angle, so I know that these two halves are equal. It gets bisected. And if they're congruent, then they're equal. So I can set these two equal to each other, and then we're just going to solve this equation. I'm going to put the x's on the right side. So 16 equals 9x plus 7. I'm going to put the constants on the left side. So 9 equals 9x. That means that x has to be 1. So again, since this is a 90-degree angle, I know that this chord gets bisected. So those two halves are equal. They're congruent, so we can set them equal. I'm going to subtract 7x from both sides and put the x's on my left side. And then I'm going to add 3 to both sides. So I get 2x equals 8. Divide both sides by 2, and we get x equals 4. And that's the front sheet of the notes. Backside. Another theorem. If two chords are congruent, then their corresponding minor arcs are congruent. Okay, so that first blank is chords. Another thing is that if two minor arcs are congruent, then their corresponding chords are congruent. So let me show you in a picture. If AB and DC are congruent, then I know that arc AB and arc CD are congruent. And vice versa is also true. If the two arcs are congruent, so if arc CD and arc AB are congruent, then I can say that the chords AB and DC are congruent. So since chord DE is 70 degrees and chord AB is 70 degrees, did I say chord? Sorry, I meant if arc DE is 70 and arc AB is 70, then that means this chord is congruent to this chord. So since this chord down here is 3, that means that x up here has to equal 3. Okay. Now they marked, with these red marks, they marked the chords as congruent, which means that the arcs are congruent. Okay, so arc VU is congruent to arc ZY. Okay, well, what is the measure of arc VU? It's 40 degrees. So this is 40 degrees. And what is the measure of arc ZY? X plus 10. So 40 degrees equals x plus 10. And then if we subtract 10 from both sides, we get 30 degrees equals x. Oh, not degrees. Well, I guess, yeah, it is degrees. 30 degrees plus 10 degrees equals 40 degrees. Yep, so x is 30. So again, because the chords were congruent, We knew that the measure of the arcs were congruent, so I could set 40 equal to x plus 10, and we get x equals 30. I am not going to have you guys worry about these last two examples. I'm not going to put any on your homework, so don't worry about these last two. I'm going to take them off your notes. So that's it for this lesson.